Welcome back. So we're going to be building this dragon now. So the first thing that I'm going to do is I'm going to make a new part file. And then we're going to save this. So I always click save to this PC. You can also save to the cloud. I don't like doing that. I'd rather just have it locally on my hard drive. Find wherever you want to save it. I'll create a, let's just create a new folder for this. So I'll make mine dragon build with you. And then I'll make a new folder called Rev1, just in case we want to make changes later, like I explained previously. And then the first part we're going to name is going to be the master. So that'll be dragon. You could just make it dragon, whatever you want. A little brief description about whatever you're making. And then this is going to be the master. So we type master and then Rev1, right? And we save that. And then we also need a assembly file. So that is like the higher level that includes all of the subcomponents, not only the 3D printed parts, but all the electronics we're going to use and any hardware or like nuts and bolts or any of that. So we'll start by, we'll make one more file and we'll do make assembly from part and then we'll drag in our master file. And then I don't know why, but whenever you drag in like a new part, it, like, let's say we had a part, it's a little hard to see or visualize right now because our part file is empty, but this F means fixed. And if we wanted to move it around, we couldn't. So the way that you fix that is you right click it, you press float. And then the thing that I like to do is I like to, so every part has like a coordinate system and an origin. So you want to like match the origin of your part file to the origin of your assembly file. So they're like all connected in like the same coordinate system. And then another thing that I'll speak about later is the way that you do that is mates. So that's like the relationship between two different parts that are moving. Like how do you define where they are in 3D printed space, or sorry, 3D space, and like how they're moving around. So the way that you do that is you press mate, and then we're going to click coincident. So coincident is just like on top of each other. So we're going to put the two origins on top of each other. So if you click this down arrow, there's the origin of the assembly file, which is this one. And then if you expand your part file, there's the origin of the part file. And we just click that, click the check mark, and then I press OK. And then also after that, it shouldn't be able to move anyways, but then I like to right click and go back and fix it so it really can't move. And then we'll save this. So same folder, I'll do dragon build with you, and then I'll do assembly rev1. Just like that. Okay. So now the next thing we do before we build our project is we need all the electronic components that we're going to use. So we need the ultrasonic sensor, the servo motor, and the stepper motor. And a good way to do that is basically these are really common parts that people have worked with before, and I've already done a good job at modeling them. So I don't think it's smart to waste our time, and I don't do this on my own projects either if it's a common part. I'll take like existing models that people have built, like even in SolidWorks before, and just like bring them into the model. So the way that I do that is I go to GrabCAD. So this is just grabcad.com if you haven't used it before. And it's like a great resource for getting 3D printed parts. I don't know what the hell that is. Library? Okay. So you have to log in. So I just log in with your Gmail. And then at the top, you pick library. And then now we can search for parts and then download them and bring them into our model. So the first part that we'll bring in, let's bring in the ultrasonic sensor. So a good way to do this, you could just type in ultrasonic sensor and it'll probably come up because that's like a very common sensor that people use for like maker projects. But if you find the part number specifically for what you're looking for, then it'll bring up like exactly what you want. And the part number for the ultrasonic sensor that we're using is HC space SR04, and then I'll do ultrasonic sensor. And the way that I usually do this is I just find one that has like a lot of downloads. So let's see here. This one has a lot. I think for my model, I use this one. So let's just do this one. So I press download and then show in folder. It'll bring up like a, so if you right click and then you press show in folder, it'll bring up like a zip folder. And all you have to do is press extract. And then, so I'll cut this, I'll press Control X, and then I'll bring it to wherever I'm saving my other SolidWorks files. So, whoops, that's the wrong spot. So I'll bring it into my Rev1 folder. Maybe I make a new folder for like, I don't know, electronics. And then I'll do ultrasonic. I just like to organize everything like this. Okay, so now this guy even built his ultrasonic sensor in SolidWorks. So we're going to bring that into our actual model. So let's go to our assembly, and then you press insert component, and then we'll browse for our part. Actually, you know what? I'm going to open the part first. So let's press open. We'll go to navigate to where you saved your part. Do you want to run import diagnostics on this part? This just means like, this guy built it in SolidWorks. He exported like a step file, and do you want to like try and recognize the features? You could if you want, but we're not going to edit the part, so I'm just going to say no. I'll save this, so just Control S. You know what? Whoops. So let's open our part. So this guy, if you look at the actual part file, so this one is a SolidWorks part file, and I think this one is a step file. So I'm going to click this one. Okay, so yeah, this guy actually modeled it in SolidWorks, and we could like make changes to it if we actually wanted to, but I like how this looks. I'm just gonna press Control S. That'll like make sure you're working in the same version for whatever this guy built his sensor in. And then I'm gonna go back to my assembly file, and I'm gonna insert component. I'll bring that into 3D space. Okay, so now we know what electronics we're gonna use. We found it on GrabCAD for free. We brought that into SolidWorks, and now we can start building geometry around it. Before we start building our dragon, let's go and get our other two parts. So the other one is the SG90 servo motor. All right, so once we find a good servo, I like this one by Ahmed. So I'll just click download. And then while we're here, let's just do the stepper motor as well. So the part number for that one is 28BYJ-48. And then I just type in stepper motor. Okay, so the model that I use for my design that I like is you got to type in capital ROHS step motor 28BYJ, and it's this one by Boris Belov. You could probably use any model that you want, but this is the one that I know that works. Okay, so we have our, now let's bring our part files from the stepper motor and our servo motor over. Oh, also we need a SG90 servo horn. Is the thing like that does the actual rotating? Okay. All right, so we'll download this one as well. All right, so now let's just bring all of our files over. So let's see. This is our servo horn. Shoot. Servo. That's our servo horn. Let's get our stepper motor. Bring that here, and then we just need our servo motor now. It's this guy. Okay, now let's bring that all into our model. I like to open the parts beforehand and just save them and make sure they work. So for the servo, open up this guy, save it, make sure it's the current version. Open up the servo horn. So the servo horn attaches to the servo and like just does the actual rotating. Save that, Control S, and then let's just save our stepper motor. All these guys model in SolidWorks. It's great. Yeah, there's another language, but that's fine. And then cancel out of here. Oh shoot, I closed my step file or my assembly file by accident. So we'll go back to our assembly file and just bring all of those components in. So need to bring the stepper in, and then our servo and the servo horn. If you press shift, you can bring them in at the same time. Okay, and then one quick thing we're going to do is mate the servo horn to the actual, to the servo. So if you, in the left hand, on the left-hand side in the tree, if you left-click a component, then it'll bring up these like arrows and stuff to like rotate your component. So we're going to rotate it over, and then we're going to click mate. So a cylindrical mate is like when two things that are round things, all round things have a center point, right? Or like a center axis that like runs through the center of the circle. So concentric just means like bring the center axis, align the two center axes of like two cylindrical things. So let's say you have a tube and another tube, just like make sure that they're centered and their axes are aligned. So that's what we're going to do here. So we're going to pick concentric and then pick any like cylindrical face here and then pick another cylindrical face on the servo motor. Boom. And then there's another one that we have to do to make sure it's fully defined. So the servo motor is going to sit so that this ring here is going to be on top of this face. And we're going to click coincidence. So now they're on top of each other. Just like that. Okay. Then you press OK. All right, so those are mated. All right, and the last thing we're going to do before we get into the building is the first thing that we're going to work on is the head or the skull of Spike. So let's make sure that the ultrasonic sensor is set up so that we can build geometry around it because we're going to be using that pretty quickly in the beginning. So one thing that we want to do is make sure that if the ultrasonic sensor, these two cylinders are the eyes of the robot, we want to make sure it's centered. So the way that we're going to do that is we're going to create a coincident mate. And in the coordinate system of SolidWorks, there's the right plane. So we're going to click the right plane, and we'll make sure that's aligned with the right plane of the ultrasonic sensor. So if you click the right plane of the assembly file and go to ultrasonic sensor and you click the right plane of the ultrasonic, boom, now they're aligned. And then I'm going to create one other mate that I just know that will work. Because I've built this already. Okay, and then we're gonna, oh, this is fixed. So we gotta right click and then press float. And then we're just gonna slide this one back a little bit. And then we're gonna click mate. And instead of coincident here, we're gonna click this front face. And then we're gonna click the front plane of the assembly file. And then instead of coincident, we're gonna do distance mate and put it at 50 millimeters back. Okay, so now this, if I show these planes, if you show them and they're still not showing, you got to click this little eye. And that'll, so this is like just like a toggle. And you can click what is shown when you hit the eye. So we got to make sure plane is selected. And then if we click this, now we can show and hide our planes pretty easily. So now, also, I didn't explain this before, but this toolbar is really useful because you can like snap to different orientations. So if I want to be like a straight on view to the front plane, I click like that, and now I'm looking dead on straight. So now the ultrasonic sensor is centered about the right plane. And if we wanted to, we can like slide it up and down. But if we go to the right view, we can see that it's also locked. Sorry. We can see that it's also locked exactly 50 millimeters away from the right plane. So now it can go like this. It can't go left and right because of that distance mate, and it can't go this way because of the two right planes are centered. Okay, so now we're all set up to build Spike. Let's get into the next part and start modeling our design.